Okay, so let's look at some of the conceptual practice problems. I need to zoom in here a little bit. It's kind of hard for me to see this. So this first page here is just directions. So in this upper left-hand quadrant, this is where the exercise will be presented, so the student will read it. And down here is where the student will answer questions. Based on those questions, they will kind of be drawing a force diagram. So they'll put in the length, they'll put in what angle it is, what's the name of that force, what causes that force, that kind of stuff. And then in this fourth quadrant, it keeps track of the X and Y components of those forces and what the net force is and what direction it points. Okay, so let's go ahead and get started in the first one. I need to zoom in again. You can see this a little bit better. So this is the first exercise. It says a light string is used to suspend a rock from a ceiling so it cannot move. So we just simply answer these questions. Does a force act on the rock? The student could say no, maybe. And if so, then the program will prompt a question. And hopefully the student will see, well, yeah, there is something touching it, so yeah, there must be a force. And then the student needs to say what angle that force would be. And let's say they have no clue, so they put in 0 degrees, because 0 degrees, might be an answer they come up with. It'll say, no, nothing's touching that angle. They'll say, well, the string's touching there, so maybe they'll put in 90. And it'll ask them how long to draw it. This is totally arbitrary. They can make it whatever length they want. So let's say 1 inch. Now they have to figure out what kind of force that is. I mean, they have to name it. So let's say they know nothing really about forces or anything like that. So maybe they'll call it a string force. And it'll say, no, it transmits via string, but it's not a string force. So they have to come up with another name. They might have to do a little research to figure it out. We call that tension. And then it'll ask them, what's the agent of that tension force? And they might not know what agent is, so they might have to come to you and ask you what that means. Or maybe you've done a little pre-teaching that they understand agent is the cause of the force, and hopefully they'll say string or the string. Does any other force act on the rock? Maybe they'll say no, that's it. And then I'll kind of give them kind of a leading question that maybe there's some other force. In this case, it's a field force. So they'll go back and they'll say yes. They have to type in what direction this field force would be, and they have to say 270. If they put any other angle in, it'll say no, nothing's touching. How long they want to draw it? Well, let's just say they make it 2 inches long instead of 1 inch. It'll say what type of force is this? And notice all these forces are being drawn over here. The black arrow is the net force, and it's kind of keeping track here. And it's not going to tell them the name until they put the name in here. So what type of force is this? Let's say they call this tension again. No, it's, they've already used tension, so that doesn't make sense. So hopefully they'll come up with this as gravity or gravitational, or weight is fine too. They can put in several different possible right answers. But there's lots of wrong answers too. So gravity. What's the agent of this? So hopefully you've talked about this already in your class, because if not, this will be a question that will drive me crazy. I'm just going to go ahead and put in the right answer. Earth, or the Earth. Does any other force act on it? They might say yes. What's the agent of the force? They might say air or something like that. And no, the air isn't touching. Well, maybe it is touching, but it's not really exerting a force other than the buoyant force, but hopefully you're not dealing with that yet. So I'm going to say maybe another tension force. No, we've already done that one. So that means I need to go back up here and fix this. I'll say no, there's no other forces. Is it accelerating? I'll say yes. Really? It says it can't move. Okay, so no. And it says now, but your net force is at 0. So you can notice over here the black arrow is not 0, and I have to adjust this to make it 0. And notice my sum is too much in the negative direction. So if I change this to 1 here, now it's right. Congratulations, I can go on to the next problem. Now I'm not going to work out all of these for you, but I thought I'd show you what all 10 of these would look like. So here's the next one. I'm not going to zoom in, hopefully you can see that. And here's the next one. It's a box being pulled by this person with a rope at a constant velocity. Here's the next one. Now it's speeding up, same type of idea, but now it's speeding up. This one here is a person, I think I'll zoom in a little bit on this one here. This one here is pulling at a constant speed, but it's at an angle, and it's at a 20-degree angle. So that's going to affect the support force, the normal, and so this is a little bit more challenging. The next problem, this is a person throwing a ball, and it's not quite at the apex of its flight. Here's the next one, same idea, but now it's at the very top. This is when you're getting in a circular motion. I'll zoom in on this one too so you can see this a little bit better. This is circular motion, and they have to draw the force body diagram for this penny. It's on this turntable. So this might be a challenge if you haven't gotten into circular motion, or it might be a nice problem to kind of do beforehand, and then you can kind of cycle back around to it when you get into the central force model. I put these 2 problems here at the end because students usually find these 2 problems to be the hardest ones. This first one is on an incline and it's speeding up, which means it's going to have a net force. And the net force when they do this is going to have to be down at this angle of 30 degrees below the horizontal here. So they're probably going to have to adjust things once they've come up with, yes, there is acceleration, there is a net force. They're going to have to kind of play around with it. So I imagine this one's going to be tough. And this one is the same idea, except it's in equilibrium. And the angle's 15 degrees instead of 30. So that is all of the conceptual questions. And then there are some quantitative type of problems. So there's over the free particle model, constant net force particle model, and central force models. So there's 79 questions divided up amongst these 3 units. I think I'll just click on this first one. Let me zoom in here so you can see this a little bit better. So this is kind of the table contents page, and so you can see the different types of problems. These are meant to just simply be a drill and practice, kind of independent mastery. These are not necessarily homework that you'd give the student. These are just extra problems. If the student's struggling, they can do these. And I just thought I'd show you one of these. I'm just going to pick one at random. Let's say this one here. Let me zoom in a little bit. And so every time they don't even have to type their name in this box, but once they type something in this box and then hit enter, it changes the numbers here, and then that would change the answers. But basically what they should probably do is print out this page, work the problem out, drawing the force diagram and solving it, and see if they get a tension of 172 newtons and a mass of 18 kilograms. And of course, here's the angle. If they don't, then they should kind of maybe check in with you, get some extra help. If they really do understand it, then the next time they try the problem, you'll notice that the numbers change. So anyway, so there's more problems here. There's lots of different problems. Like I said, every time they type their name in, it changes these numbers and these answers here. So anyway, hopefully you might find this program valuable.